So now let's look at some examples about the antiderivative. The first example, we want to know the antiderivative of 2 sine x dx. Okay, so that means whose derivative equals 2 times sine x. So we have the property that we can take this constant 2 outside. It's 2 times the integral of sine x dx. Right, so it's equal to 2 times parentheses, which is the integral of sine. Integral of sine equals what? Whose derivative equals sine? Negative cosine, right? So we have the basic rules. Then don't forget plus constant c. Then it's equal to, we distribute 2, so you have negative 2 times cosine x plus 2 times c. C is arbitrary constant. 2 times c is still arbitrary constant, right? So it's still arbitrary constant c. So this is the first example. So when you do the indefinite integral, don't forget this constant c. It's very important. 2. Example 2. So what is the integral of x squared dx? So we want to find this integral, indefinite integral. So in other words, we need to find a function whose derivative equals x squared. So we use the power rule for the basic, the power rule for the indefinite integral, which would be x to the 2, we add 1 on the power, then divided by this new power, right? Then plus constancy, so which is x cubed over 3 plus c. The third example, the integral of natural log of 1 over x plus e to the x dx. Okay, we have the property we can separate, right? We need to find the antiderivative for the 1 over x dx plus the integral of e to the x dx. Then this integral will give you that we know it's the natural log of what? Absolute value of x, not just x, okay? And the plus, there is a constant, no problem. We can write the constant later. And e, the integral of e to the x, whose derivative equals e to the x, would be e to the x itself, right? So we have another constant. So the first integral contributes one arbitrary constant. The second integral also contributes another constant, arbitrary constant. If you add 2 arbitrary constants, it will give you 1 arbitrary constant, right? So we plus c here.